And you can introduce situations where someone driving.
Is that his bag or your bags?
So that's something
Oh,
that
you took the bag.
20 years of driving.
Thank you.
And,
We lost him.
so, and I've done some quite.
So we have with him.
How many people come back?
4 to 5.
So you're at the second
I usually, so I just keep a stash in my bag. So do you live in
Being a person who balances her time between bicycle and transit research, I'm a stickler for staying on schedule because I expect the transit system to always be on schedule. So we've already lost a couple of minutes, so I'd rather jump in so that we can stay on task. So again, the second half of our session is again focusing on bike and pedestrian research, and we've got 3 excellent topics, mostly focused back in the pedestrian realm of things again. So we're going to start off with a Georgia Tech PhD student, Alice Grossman, who's working with Randy Gunsler and Anju, who's I think in the room, there she is, on a project, Educational Development and Pedestrian Infrastructure Research. Alice.
Hi, my name is Alice Grossman. I am a student at Georgia Tech working with Dr. Ginsler and with Ann Chu. We're working on a number of pedestrian, bicycle, highway projects right now that we are bringing together and doing a lot of educational development at multiple levels here in Atlanta with the local students. And I'm going to talk a little bit about what we're working on. So this is really important to us as researchers, focusing on educational development along with everything that we're doing on our own as an insular researcher in the lab, just because we need to be watching out for the next generation of students coming in, reaching out, fostering that love of engineering, love of science that we have, getting that ambition out there. And especially with things like engineering, I mean, I didn't even look at engineering as a field that would be a possibility to study until I was probably 19 or 20 years old. So bringing this into especially elementary schools and middle schools, it really brings that idea to the students at a young age, and they can start looking at engineering as something that they might be interested in and looking at it as an accessible discipline, which is also important if we're trying to get more women and minority students, people who aren't necessarily involved in the STEM, historically have those role models that maybe other students do. So our goals with these projects collectively is trying to get students to get a general background, an idea of what transportation engineering is, what civil engineering is, see that this is an accessible field, that it's a diverse field, there's lots of different skills that you need to bring to it. It's not just doing math, it's really a full-bodied subject that is welcoming to lots of different types of students. Then we're also trying to instill in them this idea of how to do research planning, which is important if they decide to go into engineering. It's also important in many other aspects of life. The same thing with collection of data and data analysis. Even if these students don't decide to go into engineering, these are important skills for them to be learning for everyday life and other fields that they might be going into. It's also, critical thinking and presentation and communication, which is really important. So we're going through these objectives in our different programs to reach those goals. This also kind of expands out not only that engineering is accessible, but that it's also an outreach to the community, right? We're trying to cultivate a social responsibility for these students. Engineering is really bettering our society. That's what our goal is, no matter what our goals are. It's trying to make this world a better place for the people who live in it. And that idea behind what we're working on is important to instill upon the students so they know why we're doing it, why it's important, and how it affects them and their communities. One of the partnerships that we're going to be starting very soon at Georgia Tech in May, I think. May or 1st? We're starting in May. We're going to Centennial Place Academy, which we're really excited about. This is an elementary school. It goes through the 5th grade right now, and they might be expanding through other middle schools. So we'll be mainly working with the older students to begin with, at least. It's a local school. They're doing the first conversion to a charter school in the Atlanta public school system, which will be happening next year. And so we'll be working with them throughout from the end of this year into that conversion to work on the project-based learning that they're trying to focus on, learning by doing, getting the kids involved. And this will be great. It's right down the street from Georgia Tech, so this is really, it's our community. We can walk there in 10 minutes. These are the students who are living near where we're living, who are involved in the community we're involved in, but also being a charter school and the fact that it's Centennial, they're bringing students in. It's a diverse student group. So they have students who live in the area, they have students that are coming in from different areas in Atlanta, they have students coming in from homeless shelters to the school. So it's really a good chance for us to work with a lot of different types of students and to get these students involved in small group activities where they're interacting with each other, they're interacting with us, and they're really doing some active learning. Some of the activities are going to focus on, especially transportation. We can really harness the fact that these are students coming from different backgrounds and from different physical areas and look at that from a transportation engineering perspective. So activities just like, how do you get to school, right? We have people, this is the city of Atlanta. I don't know how many of you are familiar with Atlanta. Centennial Place is right up there. That's just 1 block south of the Georgia Tech campus. And then down here, the Sweet Auburn Historic District. This is where the Sweet Auburn Market is, where the Martin Luther King site is, if you've been to any of those places, right down there. So that's a 1.6-mile trip that normally you would presume students would, well, in Atlanta, they'd be getting a ride from their parents. A lot of places, they'd be taking a school bus. When Ann and I went over to the school to talk to some of the administration there, they were telling us that there are parents who walk all the way from the Sweet Auburn district up to school. And that's what they do. So this feeds really well into our research. We're looking at Sidewalk. This is one of our projects, one that I've been focusing on in my research so far. We're looking at sidewalk quality, we're looking at accessibility, we're looking at pedestrian activity. So this is exactly what we're looking at, and this is the everyday lives of the students we're going to be working with. So just activities like this, looking at maps, looking at how route choice, mode choice, but from a personal experience basis, starting at that very basic level, but these are things that you're focusing on throughout doctoral research if you continue in engineering. We also want to make sure that the students understand that engineering isn't one of those sort of out there, this is really hard STEM subjects. It is math. You have to know math to know engineering, to be able to do engineering, but it's also a lot of other things. So the idea of getting the critical thinking, communication skills, organizing and planning your research, working in teams, these are things that people might not necessarily think of in the 5th grade as what engineering is, but they're absolutely key to being a successful engineer. And it's good to not only instill that at a young age for people who are going to go into engineering, but also get students who decide to do anything with their life to start thinking about these different skill sets and see that engineering really is an all-encompassing field. We're going to be working with the students. We'll be going into their school and doing 2-hour-long sessions with them. We're going to go once a quarter to do this, but we'll also be working with them between the sessions. So we'll go in during the school time. We're going to bring Georgia Tech students and researchers and research teams. We have a number of active student chapters in engineering at Georgia Tech, so we've got a big ITE at Georgia Tech chapter and a Women Transportation Seminar at WTS. And this is a good opportunity for those students also to get some volunteer work in. They enjoy working with children. We've done a lot of other outreach So we're going to be bringing students and researchers down to Centennial. And we'll start out just giving the kids a background on what engineering is, an introduction to the field, and that will be, a presentation telling them about it, but it will also be making it active learning right from the beginning. So it's not just sitting and listening, but we'll do a presentation, and then we're going to have stations that students can rotate to and see what the different fields are, what the different techniques are. We're working, as I said, there's a video counting app that you can play with on a tablet. You're really just like touching cars. It's kind of like a video game, really fun to do. We've also got the Sidewalk data collection app that's on a tablet, and we have the Commute Warrior travel diary app that's on a cell phone, that Veteran just spoke about in the other room. So we've got all of these sort of interactive projects that the students can play with, go around the room, talk to researchers, see what we're working on, and see what engineering is. From there, we're going to get smaller groups, and so the second, third, and fourth session will be small groups with multiple volunteers coming in from Georgia Tech, so a lot of individual attention, probably about 10 students to 2 researchers, hopefully. We'll see what the interest is and how many students we have. And then we'll really focus in on how do you do a research plan, what are the questions we want to ask, and then how do we go about answering those questions. So we'll start that off in the second session with the kids, do a sort of procedure development, and figure out what are the questions we're asking and how we're going to go about answering them. Then go straight into how do we do the data collection for that. So this is the research planning. Then after that session, sort of between when we come back to the next quarter, they can work with their teachers, and we'll have students going and volunteering. As I said, it's a 10-minute walk, so it's really easy for us to continue these data collection efforts, so that by the time we come back for the third time, they have their own data that they've taken. They were out in the field, they were doing it. They can go back and look at it, see what they did, see why that was important, and do some basic analyses with the data that's their very own. Sorry, going the wrong way. All right, so, yep, question 3. Okay, simple statistical calculation. After that session, we'll then help them organize their data, which is the next step, and get basically a PowerPoint presentation like this that they can then present to their peers, become leaders in their school, and also to the Georgia Tech researchers and their teachers, and show what they've done, which will help them organize their thoughts and understanding of what they've been working on, but also get that presentation and communication skill and be able to be a leader within their school. As I mentioned earlier, part of this is also encouraging everybody, but at Centennial especially, since it is such a diverse student population, getting women and minorities interested. As a young woman in engineering, I do think it's important to have female role models out there, and just to know that this is something that women do. I think that's changing a lot, but I did look at some of the NSF data that I put up for you guys here. It's not changing as much as it should be, or as quickly as we might hope it would be, and that's definitely one thing that's important to us at Georgia Tech and our research group. So moving beyond just elementary school students, we've also been working with high schoolers and college undergraduate students at Georgia Tech. We're starting a new course in the fall that is an honors college course at Georgia Tech, which is really exciting. We've been working with undergraduates for the last year in small groups. They do independent research with us, and we've been working on different research planning and data collection initiatives. The honors college course is going to be a little more structured, but it's still, since it's in the honors college, it means we can easily cap it, or we have to cap it, at 20 students, which is great because we still get that small group individual learning with them. It will be taught by Dr. Ginzer, and I'll be helping out, so we're going to have 2 instructors for a maximum of 20 students, which will be really great. And it will be one of the same idea of the interactive, even at the college level, it's still one of the most important ways to introduce somebody to engineering and see what it's really about beyond just doing lecture hall, which they get a lot at Georgia Tech anyway. So we'll be doing probably twice a week, 1 lecture, 1 day in the field, depending on the week, to really get the basics, the readings, the discussion, the lectures that they need to, but then getting them doing the hands-on stuff right away to become familiar with engineering techniques, data collection, etc. I've been mentioning what projects we're working on, what we're going to be bringing out to the students. So here's just 2 examples of the ways that we can get students interactively engaged in what we're working on very quickly. So here on the right, you can see this is a screenshot from the Commute Warrior app that I mentioned. This is on a smartphone travel diary. It's collecting your data in background. So here, this is a trip that I took at some point from over here on the east side of Atlanta, and I biked up one of the main streets and over to the west side, probably to go out to a restaurant, I think. And so this is always collecting the background. That's the passive part of the data collection. Then the active part is to be able to go back and see exactly what you did and see your own data. So personally, I enjoy looking at this. I can see how fast I was biking. I can see where I started, where I ended, what time I was taking my trip. And this is something that we can get students to do too. And that's, since it's their own activity, and they're looking back at it, it's a really good way to get them involved in the data collection process in a personal way that you wouldn't get to looking at, travel diary data that we got from the city of Atlanta 10 years ago or whatever that is. It's very personal. And then here we have the sidewalk data collection that we're working on. This is also an interactive data collection. You're taking data on the sidewalk. We have a tablet Android app that collects video, accelerometer, GPS, and gyroscope data for the sidewalks. So we're getting vibration, we're getting width, we're getting the presence of cracks, we're getting the presence of potholes. But the data collection process is very easy because it's the tablet that really harnesses all of those technologies, and Evangelos will be talking about the technology behind all of that after I am. But the data collection is just snapping the tablet straight down here onto a standard wheelchair and walking, which everybody can do. Well, presumably if the sidewalks are good enough, which is exactly what we're trying to get our data on. And so this is a good way to do the physical data collection, but also get a sense of your community and your surroundings. So like those students who are walking from the Sweet Auburn area up to their schools, they walk on the sidewalks of Atlanta every day. They probably walk the same route. A lot of people don't walk in Atlanta. A lot of people get in the car, they get on transit, and this has been a way, doing this with high schoolers and college students we found in the last year, that people are really getting to know their community better than they would otherwise. So they're getting the data collection, but they're also getting that community involvement that I talked about. One of our undergrads actually came up to me last week and he was saying, I'm so glad that you sent me out to Castleberry Hill to look at the sidewalks, because it's really cool. There's all these art galleries. I go down there all the time now. I just thought that was really great. So maybe not necessarily engineering based, but getting him out into the community at the same time. And we're also providing volunteer opportunities for our students. So that's a lot for the graduate students. We have a lot of graduate students who are interested in doing service and community outreach, and so they're coming with us to do these programs, and they'll be coming to Centennial with us. But high schoolers in the city of Atlanta also have a volunteer requirement. They have to do, I think, 70 hours before they graduate. And so we marketed this to high schoolers as an opportunity to get your volunteer hours in, but also do engineering. So be able to focus those hours on something that they're interested in, something they might want to be doing for college. As it turned out, we worked with a group of students at Decatur High School, and most of them had already completed all of their volunteer hours. They just wanted to volunteer more, and they thought it was an interesting project. But they did have that opportunity to fulfill the hours as well through the work that they did with us. The way we're organizing this, we've got professors and research engineers, graduate students, undergraduates, and everybody's kind of working together in the mentee and mentor role. So like I said, if we have graduate students working with us, they're working under our professors, under our research engineers. So we're learning through that as mentees, but then we're also going out and working with undergraduates, so that's helping me and the other graduate students if we want to become professors, if we want to become teachers, and just getting that relationship in, feeling like we're giving back, being able to learn from the students who are younger than us. We had undergraduate students who worked with us to organize the high school students. So they were coming in, they were learning from us, and then we were taking them right back out into the field to teach the high schoolers with us. And that was a really nice way to be working with them on both sides of that relationship. As I said, it's very field visit based, so the elementary school students will be going out to Centennial, we'll be going there for them. The same thing with the high schoolers. We went to Decatur High School. It's like a 15-minute drive. It was easy for us to get there. But we also did bring those high school students and give them the opportunity to come in and see the Georgia Tech facilities on campus. So they were able to see, where we were, how, just seeing the lab, where we kept the equipment, do the data analysis. For the high school students, I think that was particularly interesting for them. A lot of them were starting to think about where they want to go to college. So we walked around the campus too, and that gave them this idea of what's behind everything that we were doing out in Decatur with them. Here, these are some of the students we worked with doing research planning that I talked about. They did a lot of the Sidewalk data collection that I showed earlier with the wheelchair. This was the main project we were working on with the high schoolers. And so we had them do the research planning. They were optimizing the data collection routes. So we gave them maps, and this is what we would sit outside, we'd look at the maps, we'd do some route planning, and then they'd go out and they'd actually do the data, and then they'd go back and look at the data. So they do the planning, the data collection, and review of the data all in one day and see how the different parts of the research project fit together. Also, as I mentioned earlier, this is giving students the opportunity to use new technologies. So we're bringing in smartphones, bringing in tablets. This is all stuff that we're bringing in from our lab that can familiarize students. Okay. That they might not otherwise get the opportunity to play with. And today, this is really important, getting students that opportunity to use technology that they're going to be expected to know in college, they're going to be expected to know in the workplace. It really gives them an upper hand in anything that they choose to do instead of at home playing video games, or if they don't have the resources for any sort of technological tools at home, we're bringing this into them to give them the experience to learn methods with new technologies. Keep going, public outreach. We're not only doing outreach with the students, we're also bringing the students with us and doing public outreach in the communities. So we've been talking to different neighborhood groups, making sure, especially with the sidewalk research, you see people walking around in orange vests in a wheelchair, nobody's sitting in it, and you kind of wonder what's going on. So we've been going to their neighborhood groups and telling them about our research project, getting them excited about it. A lot of people in the city of Atlanta are very happy about the state of the sidewalks. It's not an accessible place, it's not good for elderly people to get around, and so they're very excited about our work, and it's a way to get the community engaged and to instill that idea of public involvement in the undergraduate and high school students that we're working with, to bring them with us, and they get to be a part of that too. And I already touched on this, so thank you very much. I don't want to run too much over. We have a large research group. We're working with some really wonderful people, so thank you to all of them as well.
I think we probably have time for one question. One.
In watching this, I saw a very definite gap. Nothing that you talked about led to, in the STEM, leading to science and engineering fairs. I know the one in Gwinnett County where I judge, they're all the time looking for more judges. I know the city of Atlanta, when I judged for them, they're looking for more judges. That's where you ought to focus it. Encourage the kids to take part in that and put an experiment into the science and engineering fairs.
Thank you.
All right, thank you, Alice. So we have another PhD student from Randy Ginsler's lab, Evangelos. I'm not going to be able to say your last name, Evangelos, who is going to talk to us a little bit more about the project that Alice was alluding to, the Sidewalk Sentry application.
Thank you very much, Dr. Watkins. Good morning, everyone. My name is Evangelos Palinginis. There are so many projects, ongoing projects in our lab, and I would like to talk a little bit about the Sidewalk project and mostly about the technology overview of the Sidewalk Sentry application. So here's a research highlight. Alice mentioned a lot on how we collect data. We have a non-motorized wheelchair, a tablet mounted on the wheelchair, and two people that pushing the wheelchair on the sidewalk. And here's the field of view, basically what the tablet sees. And then we collect the video that we record is processed in order to get information about GPS, accelerometer, gyroscope, widths, cracks, potholes, obstructions, and vibrational smoothness data. Basically, we can define the texture of the sidewalk. And also the results can be used for other processes, for pedestrian safety, pedestrian planning. We can compare it with, we can check if the data that we get are in compliance or non-compliance with the American with Disabilities Act, and potentially the results will promote the quality of life, improve the quality of life, and promote healthy lifestyle. So here's the outline, introduction, background, existing methods, why we are doing this, objective and scope, framework and methodology, results and validation of what we get from the algorithms, the contribution and impact limitations, and of course conclusions and recommendations. So the academic motivation from the image processing perspective, so far we know there are so many surveillance systems that are efficient in surveying and assessing the as-built infrastructure. That's the first step. Also, we know that precise detection of the as-built environment cannot be achieved with the current technology. Plus, if we are going to the Android-based application scale, we will see that there are not so many applications that can deal with more than single individual frames. Of course, we consider environmental conditions, and we check as an ulterior motive to acquire low-cost and reliable sidewalk quality-related data. The main reason why we started that project is that people don't really walk in Atlanta, and it's really important. Regarding commercial applications, just to mention that they don't really exist at this point. So probably no one really worries about this for some reason. Image processing techniques, a little bit about that. We have background subtraction methods, some examples are there, which basically cannot cope with distortion and environmental conditions while they use alone. We have feature-based detection, which produce heavy noise and low-quality images. Low-quality frames exist on tablets, that's why I mentioned that. And most of the time we have moving objects, but non-movable cameras. Here we have exactly the opposite. We move the camera, and we need to calibrate at every frame the cameras. Of course, we have methods to optimize our thresholds for the production of results, but they are not flexible while they stand alone. So state of practice. Basically, sidewalk quality and parameters, parameters associated with sidewalk quality are really important because they are linked with the perceived safety of the walkway. We have lack of information that has constrained the extraction of reliable results. Any measurements that they've done so far are limited, manual, time-consuming, so they don't really produce extended results for the city of Atlanta, or if we go to a different scale, the state of Georgia or the United States, and they rely on pre-modeled objects. We need an automated method for obtaining sidewalk-related data, information with low capital cost, the cost of acquiring the wheelchair, the tablet, and also to pay for the students. And of course, we need to assess the sidewalk quality in order to check its compliance or not with the American Disabilities Act. So here's the objective. Of course, to develop a framework for assessing sidewalk quality and supplemental objectives, including field deployment, sidewalk quality index development, stakeholder engagement, because we need to promote a healthy lifestyle in Atlanta and let people walk, let people feel safe when they want to walk. And the scope, of course, is the vision-based surveillance systems. So the framework consisted of 3 phases, 5 main steps. The first phase basically has to do with prioritization in Atlanta. We need to define the areas where we need to focus on, at least at the very beginning of the project, and these areas include business districts, transit stops, and areas where pedestrians have a high probability of walking, also areas where accidents have occurred involving pedestrians in the past. So the field data collection, we collect data in the city of Atlanta. We cover the entire city center using the Android-based application on a tablet, one non-motorized wheelchair, and one mounting board where we put the tablet and basically we prevent it from shaking. Then we get the video and we post-process in order to get all the information that I mentioned, widths, cracks, potholes, obstructions, vibration and smoothness data. All of them are linked on a second by second with the GPS, so we have the exact location where all this data have been occurred. And of course, after that, we compare the results with the American with Disabilities Act, and we develop also a quality rating interface. It's a website which will be released soon, where we rate all the data, and we also give specific information on a layer by layer, or using specific characteristics. For example, you can go and check the website, I will show you later, and check, for example, only for potholes in a specific segment. You can go to that segment, know exactly where is that place in the city of Atlanta using the GPS data, and you know exactly where the pothole exists, and you can assess that as a stakeholder, as a user, as a neighbor, or as a citizen, you can go and check. So, methodology. Field data collection. As I said, we use one standard non-motorized wheelchair, a board where we put the tablet, and of course, an Android-based tablet with a Sidewalk Sentry application installed. The data output includes a video, and here's the resolution of the video, recorded when GPS is detected. As you can see here, the GPS indicator is green, which means that we detect GPS. If we don't detect GPS, we don't record the video. We have second-by-second GPS data and high-frequency accelerometer gyroscope readings for each segment that we collect. Of course, all the data have been collected by graduate students, undergraduate students, community and high school volunteers. As I said at the beginning, I'm going to talk a little bit about the methodology, the technology behind some applications. So, regarding camera calibration, we use the vanishing point, field, angle, and height strategy. The vanishing point is where the two main edges intersect. I will show you exactly what I'm talking about. It corresponds to the points where the two dominant edges intersect, and it's somewhere in the upper half of the frame. As we look at the frame, it's somewhere in the upper half. The height is measured, the height of the camera from the ground level is measured to 1.15 feet, and the tilt angle is 17.9 degrees measured from here to here. And of course, we then converted the image coordinates to road coordinates and have precision and be able to check the reliability of our results. With estimation, here are the edges. The edges are basically produced using the canny edge and line detection algorithm, and then have been optimized with the OX methods. Basically, here is the degree of freedom that we have between the purple edges and the green edges. The green edges represent the edges of the sidewalk at the specific frame. Here's the timestamp, so everything is linked with time as well. And here's the vanishing point, the point where these two edges intersect. Given the main characteristics of the edges, and basically at each point we draw a perpendicular line in order to define a potential sidewalk width. And the sidewalk width is produced at each timestamp. This timestamp is in milliseconds, so this basically corresponds to almost 4 seconds in the video, and the 4th second in the video. Here is the actual width measurement in feet. Velocity is 0 because we don't know which are at this point. It's not a video, of course. And it's based on the average of all these edge lanes that we produce. Graph density analysis. Basically, we get the frame and we convert it first of all to grayscale and then to the binary image. And using appropriate threshold, we know exactly where potential cracks exist in our video. Using the Lucas Canate algorithm, we will be able to track at each frame, because we have almost 30 frames per second, 27 basically accurately, but the specs of the Android tablet say 30 frames per second, so we know exactly at each time point where the feature point exists and how it's linked with the previous points. So basically we know exactly how each pothole, or how the visual fingerprint somehow of the pothole or of the crack corresponds to each to each frame, and we know exactly where we go from that point. And then from the time that we get, I'm going to get it back. So using that area, which is specified, and the information from this, we calculate and update the crack coverage, and that's how we produce crack text. The same strategy is applied for the 3 main steps, basically, in order to define potholes. Here is the binary representation of the specific pothole. And basically, what we do is we split the percentage of sidewalk pavement disparities between cracks and potholes. This is with appropriate threshold. We have defined basically the threshold at sigma equals 25. If sigma is above 25, we define it as a pothole. In simple words, whenever we have a pothole, we have a darker region of pixels. So the pixel intensity is darker, is lower, it goes close to 0 when we have potholes instead of cracks. And of course, we have also obstacle detection based on hue saturation and nuance. We can get the representation of the obstructions. Of course, we excluded the first 5 feet in front of the wheelchair for processing purposes, and since we move the wheelchair, we can define all the obstacles and also check if these obstacles are moving or not moving. how we define that based on the relative motion that exists between the wheelchair that moves over one direction and the movement of the obstacles. The same we did with vibration and smoothness analysis. Basically, we got the magnitude, the three-dimensional magnitude of the acceleration at each timestamp, and it was the best way of measuring the texture of the sidewalk. We tried at the beginning to do it with image processing techniques, but given the variability that exists, and also given that we have sidewalks built from bricks, from concrete, or other materials, we were not sure with image processing techniques what was the issue in terms of texture. So the best way to define that, because we don't have absorbers on the wheelchair, was to use the three-dimensional magnitude and produce that result using the method as described. So here's one video, but basically now it's not working for some reason. Yeah, I just have to mention that. So I'll exit a little bit the presentation. I show you the video. This is the video output of the post-processing. It's not the final output that the user or the stakeholder or representative of AFC, for example, will see. This is what we see in the lab. And we can see exactly here the binary image. We have the strong links here represented, and we produce all the results and we'll be able to verify the results. So back to the presentation. We used a prototype created in Microsoft Visual C# for the post-processing level, and the main processing library over CD remains used to be as a .NET wrapper to the library, main library. And the direct and indirect output is related to high-frequency GPS. We know we have the GPS coordinates at each frame. High-frequency accelerometer gyroscope data, widths, cracks, potholes, obstructions, vibration, and smoothness data. In order to validate our results, we recorded data in the same sidewalk segment only for the purpose of validation, because the entire area of data is the city of Atlanta. And we got information about the actual sidewalk widths and the widths produced from the algorithms. And we found this difference, basically, and this is the boundary of the 95% confidence interval. As you can see, we have pretty accurate results. Of course, everything has been measured under different various weather and lighting conditions, not at night, for demonstration purposes, and with presence and absence of cliffs. Because, for example, for videos recorded in fall, we have leaves on the side. Why I'm mentioning that? For a simple reason, that we cannot define edges, we have a lot of trouble in defining the sidewalk width. Then we tested the compliance with ADA. First of all, we checked the state standards that exist for Florida, which state 48 inches or 4 feet is the minimum threshold in order to be in compliance with ADA. And of course for obstructions that nothing must be in the pedestrian access route. We went a little bit further than that, and we developed a quality rating index that can be used in the interface. And here are the measurements. We have the number 0, which represents something that did not count because of distortion, probably, or because of glare. And for obstruction, this means absence. The same for -1 means that we don't have sidewalk. We don't collect data if we don't have sidewalk. So another side impact of what we have developed is that we know exactly where the sidewalk starts and where the sidewalk ends. Very important for assessment of the quality of the sidewalks and the existence for absence of sidewalk. And then a scale rating from 1 to 5. 5 is above 6 feet with the acceptable level of 3. This is based on compliance with the ADA for the width. And of course, we have binary representation of presence of absence of potholes, the same with obstructions, and then we rate it with cracks and vibration, where 5 is the best and 1 is the worst case for each of the variables that we have here. At the very end, we have developed a web interface. Basically, we pull all the data together. It will be out soon. Dr. Genser can share more information on that. And basically what we do, we got all the data. As I said at the beginning, we use the data from GPS, so we know exactly the location of this video. And then we also use the OpenStreetMap in order to plot our results. As you can see, you can see color-based assessment of the sidewalk. Green is perfect, red is not acceptable at all. You know exactly where each point is. And you can check all the data combined or in different layers. That's another important thing, given your specialty or what you want to observe each time. So here are some of the benefits. In terms of accuracy, we have really accurate results. And of course, we can check what is in compliance and what is not in compliance with ADA, the American Disabilities Act. We can flag the areas where we don't have compliance with ADA. Of course, from the image processing and mathematical perspective, computer vision, it's really important because we found adaptive thresholds in order to define and differentiate between cracks, potholes, and obstruction. And of course, if we look at the big picture, we can see that this is a very useful tool for overcoming economic restrictions by creating an efficient means of identifying and evaluating problem areas. As I said at the beginning, the main issue is that people don't walk the plan. And the best way to interpret the results is to visualize the results and make it realize what is the real drawback of what is going on at this point and why we don't really walk. Of course, nothing is perfect. First of all, the sidewalk must be in the video feed. The tablet looks in another direction, you cannot really get any information. Of course, all the people associated with data collection were trained properly, but sometimes we can have issues, especially when we try to overcome a tree encroachment. So the wheelchair has to go up and down at the same time. For some time, we lose some data because we point on the sky. In that case, we don't get any information. Of course, we need to check the integrity of the calibration matrix. We don't have results under severe distortion because we are losing the vanishing points, so we don't really define edges. And a main drawback of the tablet, which, though it's not really a drawback, we knew that from the beginning, is that we have a relatively narrow tablet view angle, which of course is enough for the sidewalk, a typical sidewalk width, but for example, whenever we have sidewalks of 30 or 35 feet, in the real case, most of the time, we cannot really produce very solid. So here is the research impact. We developed an Android-based application to assess sidewalk quality, collaboration with Betty and all the other students, research engineers, and of course, under the supervision of Dr. Gensler. We created an objective database of sidewalk locations and quality ratings. We can estimate the compliance or non-compliance with ADA. We can potentially improve the quality of life as a side impact of what we produce because we provide basically a visualization of what is going on and how accessible is each sidewalk per location. And of course, we also obtain second-by-second traces regarding the quality of sidewalks, for example, with cracks, potholes, vibrations, obstructions, and obstacles. Future research in terms of mathematics and computer vision, we need to check more complicated sidewalk segments in terms of architecture, let's say crossings or very wide sidewalks. And we can also fully automate the calibration with video. And from computer vision perspective, we can minimize the effect of glare, we can minimize the effect of distortion in order to basically increase the level of accuracy and increase the number of results that we produce per specific segment. Thank you very much. Here are our contact information, my name and my email, and also my advisor's email regarding information and questions that you have regarding the website. Thank you very much.
That's me on the left.
Yeah, well.
Maybe we'll take time for one question. Is there?
Yes.
Yes, you get the floor.
Okay. First off, I would suggest you add 82 senior zones into that system because we need the sidewalks evaluated and then give the information to Richard Mendoza, Commissioner of Public Works. Secondly, you mentioned about a 1.5 foot eye height. Is that really the eye height for a person in a wheelchair? And what about the 3-degree field of vision, primary field of vision? That was not covered. And you've got a lot of, in your table you showed Atlanta, not applicable, about 4 intersections, 4 areas. And I think if you had reviewed the senior zone policy for the city of Atlanta, you'd have found that there were answers about that. Because talking to the person that wrote it, I know ADA and other things were considered in there, plus what happened in Broward, Florida. So I think you missed the point.
First of all, we described the technology overview of that project. Regarding the policy and why we did that, there are plenty of other, and probably we can address other questions that I am providing the image, and also Alice introduced a little bit about the policy perspective of that and how stakeholders are involved and what's the side benefit, what's the real benefit for the entire population. So regarding the technology overview that I presented today, the 1.15 feet is linked with the height of the camera in the sidewalk, on the wheelchair. I can pull out the image again. I think it's at the very beginning, yes. So here, that height from the camera, which is here, pointing down, is 1.15 feet. We did that for camera calibration purposes. If we don't have camera calibration, we can produce a width that is not realistic. For example, we can find 10 feet and this can be 6 feet. In order to produce reliable results, we have to calibrate the camera. And that height corresponds to the height of the camera. Any other questions?
That's not the eye height for the person in the wheelchair.
It's not supposed to be.
The two
It's
don't
not
need
supposed
to
to
be.
be.
Right. It's calibrating the field of view so you can get the correct
Exactly.
distance measurement.
Field of view is 3 degrees. I did not hear that discussed at all.
It's not relevant to this.
Yes, it is.
This is
The
for,
MUTC defines these things.
excuse me, the technology here is to estimate the width of the sidewalk. That's all that Evangelos is talking about. And you need a 1.15 foot height in that calculation. That's all that's related to.
Okay, I think we're going to move on to the last speaker at this point. Thank you. Can we give a hand for Evangelos? There we go. So our last speaker is Hamidreza Asgari. Okay. And we welcome him from FIU. So.
Hello everyone, I would like to welcome you all to my presentation. So actually I come from FIU and I'm representing FIU GIS Lab under supervision of Dr. Sharjin. So over there we work on travel demand analysis, statistical models, and behavioral studies. So I guess what I want to talk about is a little different from what you've seen in the presentations today. So first of all, let me talk about the topic. We're going to investigate the temporal variations in non-mandatory activities. And actually, we came up with something new. We considered a new concept as shoulder days. And we're going to consider shoulder days versus midweek days. So this is the outline of the presentation. I go through the objectives, motivation, the National Household Travel Survey, activity types. I talk about participation rates, duration, and also I go ahead and investigate the modeling results. Actually, the major objectives of this presentation is to go ahead and investigate activity travel patterns. We're going to model discretionary and maintenance activities, which I'm going to explain later with all the details, what they mean. And we're going to consider 2 different dimensions, the participation rates and the duration. And the major objective is to investigate the temporal variations by using interaction effective variables versus weekday categories, which I'm going to explain in details during the model results. So, the idea of dealing with activities mainly comes from the ABM modeling, activity-based modeling, which means trips or travels are actually derived from activities. It means people do not make trips just to make trips. They make trips to accomplish some activities in the destination. And we're going to discuss the remarkable impacts of activity scheduling on transportation issues. The previous emphasis was mainly the difference between weekdays and weekends. So I just gathered some literature review over here. But what we're going to do is that we're going to exclude weekends completely, and we're going to see how temporal variations happen during weekdays, which means from Mondays to Fridays. So we got the data from the National Household Travel Survey 2009, and we had a sample of 25,702 individuals, one selected randomly from each family. So we got one member randomly chosen from each family. So we consider 2 main aspects of each activity, which is going to be the average daily participation time or average daily duration in minutes, And we also have the participation rates, which is actually the percentage of participants in each activity. So as you can see, we considered 3 different temporal categories, which is going to be Mondays and Fridays, which we define as being shoulder days, which means the days which connect midweekdays to weekends. And we also have midweekdays, which consist of Tuesday, Wednesdays, and Thursdays. So as you can see, the participants in the sample, they are randomly selected member from household, ages 15 or older. There are no gaps on survey, which means the data is collected continuously from 4 a.m. to 4 a.m. the next day. And we derived activities from main trip purposes because this was a travel survey, not an activity survey. So we derived activities from main trip purposes. So this is a continuous out-of-home activities. We also considered non-travel activities in terms of being at home completely. And the activity types of interest are non-mandatory activities because, you know, for mandatory activities like school or work, there is not that much decision making because you have to do it on a routine basis. So we had household maintenance like retail shopping. We had personal maintenance like doing personal stuff like going to barbers and so on. We had social activities. We had meals and exercise. So this means we considered 5 different types of activity purposes. And the temporal analysis, as I said, we have 3 different sections, Mondays, Fridays, and midweekdays. And we made a major assumption, that is, instead of a drastic change from weekdays to weekends, what we usually used to see in literature, now we consider that there might be a gradual shift happening through a transition period. And though that transition period is actually Mondays and Fridays, which connect midweekdays to weekends. So, just like any other data analysis, we did some descriptive statistics. So as you can see, this is the average duration. So there are some different participation rates observed among different weekday categories. For instance, you can see that on Fridays, individuals tend to spend more time on social, meal, and household maintenance. But they allocate more time to personal maintenance activities on Mondays. And we also considered participation rates. Again, we have different patterns on different days of the week. As you can see, individuals are more likely to take part in household maintenance, social, and meal activities on Fridays. And midweekdays show the highest participation for personal maintenance and exercise. And we also considered both dimensions together, which means participation rate and activity duration. So we considered 15-minute intervals, and we noticed that almost all activity types, actually the diagram you see is only for household maintenance, but all the activity types follow the same pattern, which means individuals either do not participate in activity or they spend at least more than an hour for that activity, which may be explained through the trade-off between the travel costs, the time you spend. So, for econometric modeling, we came up with a discrete continuous sample selection model. So, actually discrete continuous models are mainly used in economics, which means whenever you want to buy a product, you have 2 different dimensions to decide about. The first one is which one to buy, or whether to buy it or not, which is a qualitative choice. And the other one is what is the required amount, or the quantitative dimension. So the same procedure was applied for activities, which means first we have the decision making to see whether to participate in an activity or not. And the second one, if the answer is yes, how much time or how many hours we're going to spend on that. So the first decision making, which is a yes or no, and if you're familiar with the statistical models, this could be described in a discrete binary choice model, which can be used in normal distribution, binary probit, or logistic distribution, binary logic model. And if the result is yes, we're going to have another model which shows us the duration, which we use the simple linear regression model. So we use the joint sample selection model, which was formulated by Hall. So we have two different dependent variables. The first one, y1, which is the duration, is only observed when the second variable, y2, is positive. y2 is actually the latent variable for the binary choice model. So we have a simultaneous formulation based on the maximum likelihood function, which can actually estimate the coefficients for the duration, which is the linear regression model, the binary probit model, which is for the choice, and also the correlation, as you can see, the value of rho, the correlation value, which shows the correlation between the two decision makings. And also we have sigma 1, which is the standard deviation for the duration. So we use SAS software to come up with the modeling for all types of 5 activities. And our analysis was considering 2 different steps. First, we only used main effective variables to come up with basic models for both duration and choice. But remember, the very first objective of this study was to consider temporal variations. So after coming up with the basic models, we considered interaction effect of some of the chosen variables with the weekday categories to see how they impact the model through different temporal categories during the week. So this is actually one of the examples of the models we came up with for household maintenance. You can see the first 2 columns, which is for the choice one. We have the coefficient and the t-test, which shows how significant the variable is in the model. And also we have simultaneously modeled the duration with the coefficients and the t-test. So as you can see, I have only showed significant variables here. So we did the same thing for all the other types of variables. Sorry, purposes, personal maintenance, social, meal, and exercise. So I'm not going to go through the details because I don't want you to get bored. I'm just going to give you some general results. So the main factor in simultaneous modeling is the correlation between the 2 decision makings. So only 2 of the purposes, social and exercise, showed significant values of correlation between the 2 decision makings. And the correlation was negative. It means if there are unobserved factors affecting both of the decision-making levels, they're going to have contradictory effects on choice and on duration. So it means in all the other cases, the joint structure has no preference over separate modeling. We tested it and the results were 90% the same. So I chose one of the activities for presentation here, household maintenance. So as you can see, we analyzed some of the variables to see how they impact the model. So you see, like for the choice dimension, being a licensed driver, having higher education, and having a medium income. By medium income, I mean between 50 to 75 grants per year, are the 3 highest positive impacts on choosing household maintenance activity. It means people who fall through these categories, generally, they are more likely to choose household maintenance activity during their daily schedule. And minor individuals, which means individuals under 18, either male or female, along with male senior parents, are less likely to choose household maintenance on random days. And for duration, we see older people and people coming from large households spend more time on household maintenance. And also, gender has the highest negative impact on duration. By gender, I mean males. So accordingly, males spend less time on household maintenance. So these were general results without considering the temporal variations. So for the next step, we considered the effective interaction variables. So we made 8 different hypotheses. By hypothesis, I mean we hypothesized whether these variables have any impact on different temporal categories of the week or not. So first we considered only, let's call it the constant interaction, which means we didn't consider any variable but the temporal categories by themselves. So we saw that only Fridays are significant at 95% level of confidence, and individuals are more likely to accomplish household maintenance on Fridays. As you can see, the positive value shows the positive impact of Fridays on household maintenance. And for duration, all the categories are significant, and in comparison, individuals tend to spend less time on household maintenance during weekdays. So it means people do less household maintenance on Tuesdays, Wednesdays, and Thursdays. the next step, we considered age. And again, we noticed that Fridays are important. You see, as individuals grow older, they are more likely to accomplish household maintenance activities on Fridays. And again, for duration, older people tend to allocate more time to household maintenance on Fridays because, as you can see, the negative value here is the least among the other variables. So we also consider the driving license. Again, you can see the impact of Fridays. So licensed drivers are more likely to choose household maintenance on Fridays. And for duration, as you can see, all the three categories are significant, but as the value of the coefficients were very close, I just did a statistical testing, and we noticed that they are not that much different. It means Fridays, weekdays, and Mondays are not that much different in terms of licensed drivers. So we also consider gender interaction. We noticed that males are more likely to carry out household maintenance on Fridays, while females are more prone to choose it on midweekdays. So females are more active. And for duration, we see that males spend more time on household maintenance on Fridays compared to Mondays and midweekdays. We also considered the impact of income. So we had three different categories of income. We had less than 50 grants per year as low income, between 50 to 75 as medium, and above 75 as high income values. So we see that low income individuals on Fridays and high income individuals on Mondays have respectively the highest positive and negative impacts on choosing household maintenance activities. And in terms of duration, we notice that high income individuals on Fridays spend less time on household maintenance activities. And then we have employment type. 3 different employment types were taken into account: full-time workers, part-time workers, and people who hold multiple jobs. So again, we see that full-time workers are less likely to choose household maintenance on Mondays and midweekdays, while multiple job holders are more likely to do it on Mondays. I guess these results need a little more analysis. And for duration, full-time workers spend the least time on midweekdays, while multiple job holders spend the most on Mondays. So I guess the relationship between Mondays and multiple job holders should be considered later. So we also considered land use. We had 2 types of land use, urban and rural. So as you can see, individuals residing in urban areas are more likely to accomplish household maintenance on Fridays. And for duration, urban residents spend less time on household maintenance activities on midweekdays. And we had 12 different family roles. So I only consider the significant ones here. So as you can see, in terms of choice, single males have the highest positive impact, while minor females on Fridays have the highest negative impact. And in terms of duration, as you can see, single parent males and again, minor females on midweeks have the highest negative impact on the duration. So actually, what we did here showed that we can model activity participation and duration jointly in a discrete continuous framework, which is widely used in economics, but we use it in transportation-wise. So we noticed that 2 activity types show significant correlation values, including social and exercise. So we made various hypotheses regarding the temporal variations, and we noticed the significant impact of variables. So results indicate that most of the variables showed significant contribution of interaction effects in terms of temporal categories. Thank you so much for your attention. If there's any question, I'm more than happy to answer.
It looked like age was being used as a linear variable in there for a lot of it. Did you try like Kitamura's life cycle stage discrete variables?
Actually, the major policy was not to categorize continuous variables into discrete variables.
Right.
So all the other, because we had actually, this was done with corporation of UF, so we used exactly the raw data they provided for us. So we didn't make any changes.
It might be fun to look at those just to see if you see any
Sure.
differences. Yeah.
Thank you so much.
Well, can we get into
So that comes to the end of what we've got. I think most of the speakers from both the earlier session as well as this one right here are still here. So lunch starts in about 10 minutes, and I believe it was downstairs in the atrium. Someone quickly, I see nodding, so I must have gotten that part right. Be down there at about noon for lunch, and in the interim, if you have questions or such, I'm sure all of these folks would be welcome to take them. So, thank you very much.